Geometric sequences can also be written as first-order difference equations. In this instance, we don't have a common difference, so I'll just erase that. So we end up with the common ratio times the previous term. Now, once again, we have to define where we're starting. So in the instance given, the next term is equal to 3 times the previous term, defining the start position at 5. Working through 3.2, starting at 5, and simply doubling to progress forward. The next instance, commencing at 1,000 and halving that. And in the last instance, -5, so that will alternate above and below the axis if we were to sketch it. Etc. Writing down the rule here, firstly we've got to find the common ratio. In the first instance, we're multiplying by 3. In the second instance, we're multiplying by 0.5 or a half. We've got the first number there, we'll call that T1 is equal to 4. And the rule, Tn plus 1 is equal to 3 times to the n. In the next instance, we could call that times a half or times 0.5. I'm happy with either. Tend to use 0.5 for our calculator purposes, I suppose. And here, T n plus 1 is equal to 0.5 times t to the n, and our starting point is 128. Now, the next problem, we're asked to go from the geometric sequence formation into a difference equation. Well, let's write out the first 5 terms. Now, that's when n is equal to 1, 2, 3, 4, 5. So that commences with 2 and then moves to 10, 50, 250, 1 to 50, etc. Common ratio is equal to 5. So if I'm to write that in a difference equation format, where T1 is 2. So the key difference, excuse the very bad pun, is we write the next term in terms of the previous term, but have to define where we start. Related, but not quite the same in the presentation.